must have common denominator. That is the rule. So again, we didn't have to do that for multiplication and division, but we've got to do it for addition and subtraction. Okay, so we're going to start off with a very, very simple rational addition problem. You've definitely seen this before, okay? So I'm going to write this kind of in a better way so it looks more like two fractions instead of numbers with slashes, okay? So we've got 1/3 plus 4/5. So what we want to do when we're adding and subtracting fractions is we just want to look at their denominators. Okay, we've got to find that common denominator. So what I mean by that, I don't mean find a number that they have that goes into both of them, but instead I want a number that they both go into, okay? We call that converting. So 3 and 5 will both go into, yeah, we got it, thank you. The anticipation was building. Okay, 15, they both go into 15. So now what we do is we look, okay? We look at the very first fraction individually. To get from this denominator to this one, what do I need to multiply by? 5. So I'm going to do the exact same thing on top. And 1 times 5 would be 5. And now we do the same thing with the other fraction. 5 to 15 I need to multiply by 3, and 4 times 3 is... And now we can just add straight across, but be careful on this, okay? When you add straight across, you keep that denominator. You do not do 15 plus 15. That is not how this works, okay? You keep the denominator, and then you add the tops. So 5 plus 12 would be 17. Can that simplify? 17 over 15? Nope. I'm not going to simplify. So that's it. Questions on that?
Why not turn it into a mixed number?
Why not turn it into a mixed number? I don't care if you do, it's just more work. If you want to do that. But yeah, I wouldn't do that. Okay. Now we're going to do this, okay? But now we're going to add in a little algebra, okay? So that was just plain old Jane math, but now we've got some algebra that we're going to throw in. Same thing applies though, all right? We're just looking at the denominators. So I'm looking at the 7 and the 8. I want something both of these will go into. They'll both go into 56, right? Good. Did you get 56 by just multiplying the two numbers together? Yeah, that always works. Okay, whenever we have monomial terms like this, you can always just multiply the two together and that can be your common denominator. Okay, sometimes there might be something smaller. In this case, there's not. Okay, like something smaller that 7 and 8 might both go into, but 56 is going to be your smallest, and it happened to be the two values multiplied together too. Okay, so now what? Okay, so the first one, to get from 7 to 56, I multiply by 8, so 2x times 8. Okay, and then to get from 8 to 56 times 7. What is that going to be? 42x. When we add across, what do we have for the denominator? 56, it stays, good. And then on the top, 58x, perfect. Okay, now what we see here, we've got a monomial over a monomial, a single term over a single term. Can we simplify those, if possible? Yeah, is there something we could divide both those by? 2, okay. What happens when I divide 58x by 2? 29x over 56 divided by 2, 28. That's it. That's all we got. For real. Okay, not too bad. Let's keep going. What's different about this one? Well, we still have to do a common denominator, but we got x's in the denominator, right? Okay. What'd you say?
Wouldn't it just be 1?
It's not going to be 1 because we've got to get something that both denominators will go into. So something that x will go into and 2x will go into. Yep, they'll both go into 2x. You got it. They will both go into 2x. Okay, go ahead and finish that one. All right, so what do we do on that first fraction? What do we need to multiply by, or in other words, what are we missing to get from x to 2x? Just 2, right? Okay, so if we multiply by that on top, we get 2. Okay, now the second one, to get from 2x to 2x, am I missing anything? Do I need to multiply by anything? No. Just, yeah, you can multiply by 1, or you could just leave it alone, right? So what's the top going to be?
1.
Just 1. So my final answer would be 3 over 2x, and will that simplify? No. Good deal. How we feel about these monomial terms? Easy? Terrible? Easily terrible? Or terribly easy? I like that better. Okay, example 3. What we got now? What do we notice? Yeah, 2 things. Subtraction instead of addition, and then we've got binomials, okay? We talked about this back with the multiplying and dividing unit. Our 2 binomials, like once they've been factored, if they're not the same, are they ever going to be the same? No, they're not. They're 2 different things, right? So, would you agree that both of those binomials are fully factored, meaning I can't take out a GCF, I can't do difference of squares, nothing like that, okay? They're fully factored, and you also agree that they're not the same. They're different, okay? So here's what we got for a common denominator. We need both. I need this one, and I need this one. Okay, so they are both going to be a part of my common denominator. And I'm still going to write out my common denominator twice for both fractions. Okay. So does everybody see how I got that common denominator? Cool. So now we're going to do the exact same thing as what we just did. I'm looking to get from x minus 2 to this whole denominator. What am I missing for the first one? Get from here to here. What do I not have? The x plus 3. So that's what I need to multiply the top by, is x plus 3. So this is distributed, and yep, you're right, 2x plus 6 is what I got. Okay, we're doing the same thing on the other one. To get from x plus 3 to this, what do I need to multiply by? X minus 2. Okay, be really careful though on this, okay? When we go to distribute, am I distributing a 7 or a negative 7? You got it. So what I can do is I can take this negative, and before I distribute, I put it up here, and I change this to addition. Okay, so now I'm distributing a negative 7, so this becomes negative 7x plus 14. You got it. Why? Because I just moved this negative up here and I distributed it. Okay, if I wouldn't have done that, I would have just brought it down, but I still would have had to distribute that in the end. So I just saved myself some time. Okay? So if we're...
I forget, like when we're taking the test, to change it to multiplication on the answer, is that wrong still?
Not change it to multiplication, change it to addition. Yeah. If you don't distribute out, because what's going to happen is if you don't do that, then this would become this would stay a negative 14, which is going to give you the wrong answer.
Distribute it as a negative because it doesn't make
So you're saying what if you would have distributed as a positive 7? If you wouldn't have seen that?
Yeah.
So what would have happened is that down here you would have had, hold up. You still would have had your minus sign right here. Okay? And then you would have had this right here, 7x minus 14. But technically, Cameron, do you see that this negative right here still has to be distributed because we're subtracting the whole thing?
Oh,
So then I would distribute it down here, and I'd still end up getting a negative 7x and a positive 14x.
okay.
Okay? You got it?
Yeah.
Good question. All right, don't appreciate all the side chatter. Let's get through this, though. What do I need to do now? What's going to be the denominator? What's going to be the denominator? You got it? And then what about the top? Negative 5x, because you did 2x plus negative 7x. And then you said plus what? 20, because 6 plus 14 is 20. Good. Last thing, though. When we have an answer, it's got to be fully factored. Is the top fully factored? No, unfortunately it's not. What can I take out? No, not 5. Negative 5, because it's a leading negative term. So then it becomes x minus 4. Okay. Will anything simplify here? Do I have any of the exact same binomials or monomial terms that can simplify? No, so I'm done. It's not so much work. You're capable. All right, we've got 1, 2, 3, 4 more problems, guys, and we're done. We can do it. Okay. Looking at number 4, I look at my denominators. Are those fully factored? No. How do we factor those things? X method, right? Because they are trinomials. All right, I want you to go ahead and just factor the denominators. And then go ahead and give me a good guess on what you think the common denominator is going to be. We've talked about how you need everything, okay? So go ahead and factor these and then tell me what the common denominator is going to be. So we said we do X method, right? So our first X, what's it look like?
6 on top and negative 5 on bottom.
Okay.
And negative 3 and negative 2.
Good. Negative 3 and negative 2. Multiply to 6 and add to negative 5. So your two factors would be what?
X minus 3 and x minus 2.
Perfect. And we can scratch this thing out because that's our new denominator. Okay, what about the second one?
Negative 2 on top 1.
Negative 2 and negative 1.
And then negative 2 and then positive 1.
Perfect. Negative 2, positive 1. X minus 2, x plus 1. And there we go. Okay, so we have factored both of these denominators. So now we look and we try to find a common denominator. Any guesses on what that's going to be? A couple of us got it.
Negative 2.
Okay, so they both have x minus 2, right?
Yeah.
Okay, I would agree with that because I can look here and see they both have x minus 2, so I just need to have that one time. Okay. What about those other two things, though? Don't we need everything?
Yeah.
Yeah, so we've got to have those two. I need this one, and I need this one. So my whole common denominator is going to be x minus 2, x minus 3, and x plus 1. It could be in any order that you put it in. Okay, good deal. Questions so far? Could have been bad. Okay, so now we look. That first fraction to get from this denominator to this one, what am I missing? What do I not have? The x plus 1. So that's the only thing I need to multiply by. Okay, when I distribute a 1 out, what do I end up with? 1x plus 1. Same thing on the second fraction. To get from this to this, what do I need to multiply by? You got it, x minus 3. But I'm distributing a what? A negative 2. So make this plus. Negative 2x plus 6. You got it. So now we end up with, what is our final answer going to be? Negative x plus 7 over perfect. That's it. All you gotta do. You could take out a negative 1 on the top, but you really don't have to because it's not gonna do anything. Yep.
Would you have to put the divided by 2 in front of the negative x plus 7 or not?
Divide by 2.
Yeah, never mind.
I'm confused your question.
What?
Do you help him?
I thought you had to divide.
Nope, we're just adding across. Yep. Okay.
So on the denominators, whenever you have all three of them, you put them together, do they have to be in the same order for each one of them?
For both?
Yeah.
I mean, not necessarily, but it helps. But yeah,
I forgot to put them on
So it's
not in the same order.
they're not the same as like what I have written. It's okay. You can put it in any order of the 3. Yep.
They're just not in the same order, essentially.
Okay. As long as you know what you're doing, you're good. Okay. We're almost done, guys. We got 3 more. We got to get through. I'm going to give you about 2 minutes. I want you to do number 5. You're perfectly capable. Okay? Factor both denominators. Find the common denominator. And solve this. Guys, one thing I want to make note of as you work through these problems, okay? We are no longer canceling things out, okay? Because we're not multiplying and dividing. So whatever you do, don't do this from the get-go. It's going to be wrong, okay? Because this is adding and subtracting. It's not multiplying and dividing and simplifying, okay? It's different. Think you got it? Okay, let's go ahead and start this one. So, first thing we do is we factor every single denominator. So we start with the first one. You should be paying attention. If I see your phone out, I'm writing you up. I'm over it. I'm so over it. Okay, so we factor both denominators. We start with the first one, x squared minus 9. What can that do? Square root of both terms, and it becomes perfect. X plus 3, x minus 3. Will the second denominator factor? Nope. So now we need to find our common denominator. What's it going to be? X minus 3 and x plus 3. Good. We got to have them both. We have to have everything. Okay, now we start with the first fraction. Okay? To get from this to this, do I need to do anything? No. So what do I do? Just write x minus 3. You got it. Okay, now to get from x minus 3 to this, do I need to multiply by anything? What? Yep, I'm missing the x plus 3. So I multiply the top by x plus 3. Yep, don't forget your negative. So we make it a plus and make this a negative 1. Distribute. And what's it become? Negative 1x minus 3. Perfect. So we add straight across. Our denominator will be what? X minus 3x plus 3. And the top. Just be negative 6. Yep. The x's cancel. X minus 3 minus 1x minus 3 is just negative 6. And I'm done. Okay. Questions on that? No questions about that? All right, let's keep going. Number 6 looks a lot harder than it is, okay? We look at our denominators. Are those monomials or binomials? Monomials, okay? So we just need one term that all of these will go into. Okay, so all the numbers will go into 4, I agree. So 4 plus 4 minus 4, okay? What about the variables? We just need x, y. You got it. That will encompass all of it. Okay, so first fraction, to get from 2y to 4xy, what am I missing? What do I need to multiply by? 2x, good. And 5x times 2x would be 10x squared, good. Second one, 2x to 4xy, I multiply by 2y, so 4y times 2y. Perfect. And then last but not least, 4xy to 4xy. Nothing, but there's one thing I need to see here.
It's negative 10.
Yep, this negative still got to be distributed here. So it's negative 10x squared minus 5y squared. Good, 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 good. So my denominator is still going to be 4xy, and my numerator. What do we think? What's going to happen here? Yeah, 10x squared minus 10x squared cancels, and then 3y squared. Got it. Okay, I would count that right on the test. However, I might even give a little bonus point here if you could see that this can still be simplified. There's one more thing I can do here, since these are both monomial terms. The 3 over 4 is not going to simplify. Can't do anything with the x. But what about y squared over y? Don't we just subtract the exponents? So it's just y. So it's just that. If you see it, great. If you don't, it's okay. As long as you can get to this point right here, I'm happy. Okay. Last one. Give you about 2-3 minutes. Solve this one. Okay. We'll go over it. We'll call it a day. Okay, what do we do first? What'd you square root? The x squared minus 1. Okay, what did that become? Good, x minus 1, x plus 1. So your common denominator was what? Yeah, you gotta have both of them, right? X minus 1, x plus 1, whichever order you did it. So write it out 3 times. Okay, first fraction. Need to multiply by what? Say what? Yep, it's missing the x plus 1. When I distribute it out, what does it become? 2x squared plus 2x. Remember? Okay. Next one. Multiply by x minus 1, and that would become 2x squared minus 2x. And then last but not least, what's that last numerator going to be? Thank you, Nick. Negative 5x squared. Perfect. Plus a negative 5x squared. Okay, and then last but not least, my denominator stays the same, right? Which is going to be what? X minus 1, x plus 1. And then on the top, what do we got? What x? I don't know about that. Negative. So 2x squared, negative 5x squared. Negative 1x squared. And then 2x minus 2x. Nothing. So that's it. Negative x squared or negative 1x squared on top. Give me 1 second. All right. So that is it on notes. Your homework is to do Delta Math and then the homework sheet. Okay, you've got to do both. You must have the Delta Math done today when you walk out. So that's what we're starting with.